You mentioned that in your model, individuals still need to be doing better. So in heterodox group, we still need to be doing better with individuals and less heterodox group, right? Can you speak to the notion actually how that really matters to the proper unit selection? If it's the case actually that individuals are still doing better.
Right. So it goes back again because within a group. If you took a group and isolated and just had them reproduce within that group, then again, those individuals that are at a disadvantage within that group would eventually be selected out of it. And so in our model, what happens is we basically have, it's a very sort of David Sloan Wilson kind of model, where you have a group, they succeed by their rules of diversity or whatever, and then they reproduce, and all the reproduction goes into sort of a common pool, and they get seeded out into groups again. And so what happens again is those diverse groups simply contribute a lot more individuals into that offspring pool, and then so on. So if you don't have that dispersing stage, if you sort of again isolate the groups, then again eventually either genetic drift is going to kill the diversity, or whichever allele has whatever kind of selective advantage within the group is going to eliminate everybody else. So you can only get it with this sort of Wilsonian kind of group reproduction, dispersal, reforming of groups kind of thing. That's the only way it works.
So it's intriguing synthesis, and I'm not certain that I have it all in my head, but I'm not sure how your combination, your reformulation of E.O. Wilson's version with heterosis solves the greenbeard problem.
Oh, it doesn't solve the greenbeard problem at all. No, it doesn't solve the greenbeard problem at all.
And it even seems like it introduces a new form of a greenbeard, which is I can claim to be different and social and actually be the same as social. So I'm not contributing to the heterogeneity advantage of the group.
Yeah, I mean, you can. I mean, again, we sort of tried to get away from in many ways describing what the advantage is, and just again sort of saying is the advantage of having you in the group is that you are different from me, different from Brooke, different from someone else, and these differences in some way produce a group phenotype that's more capable, and it's not anything that you necessarily offer to the group other than yourself.
Right, I understand that. But suppose that there's some constraint on group membership, the total size.
Oh yeah.
Only so many critters can inhabit the nest, or whatever it is.
Yeah.
Okay?
Yeah.
And so I'm nominating myself as a prospective member of your nest. Okay. And I say, you and I share this greenbeard sociality trait.
Yes, exactly.
But I'm different from you, so you want me in the group.
Right, exactly. So it's an anti-greenbeard.
Right. But in fact, I'm just like you. Okay.
So you're faking it.
I'm faking it. Exactly.
Right.
It's just another form of the greenbeard problem.
Right, exactly. So yes. So in essence, if you were choosing members of a group and you wanted diversity, then yes, you would choose individuals. So I have a green beard, so I'm not going to take anybody else with a green beard. I'll take somebody else with a red beard or something, and so on. So yes. So it could be the same problem there, and we haven't explored that aspect of it because we just had the group sort of form randomly. Now we didn't have any sort of group association rules. So nobody was choosing other group members. Nobody was excluding other group members. Groups just happened to randomly form. And what would happen again is that there was sort of an optimal group size for this to work. If the groups are too small, you can't get that much diversity, right? There's just not that many slots for individuals. If the groups get large, by random chance, they tend to become more and more similar. And you have less and less across group selection and more within group selection. So somewhere around 4 or 5 was better for social heterosis to work. You make the group larger, it doesn't work as well. You make the group smaller, it doesn't work as well. But we didn't look at anything like, okay, as terms of choice, okay, who actually can be a member. Now again, in a trivial sense, right, we all know that we choose for genetic diversity. I mean, we don't have sex with our close relatives. Right? And you can come up with, okay, there's reasons for that, and we have sort of incest biases and so on, but there's good reasons for that. So in essence, there are ways you choose for individuals that are different. So this is, again, outside the reproductive context. So we're not sort of saying that the choices are made because genetically diverse groups are less likely to suffer from incest, although that's, again, a potential advantage. But we're just sort of saying, okay, genetically different groups are just better able to deal with different things.
So I can see how you get the, I mean, I sort of follow where you've gone with this, but I'm wondering, can you get with your mechanism alone to the elements of your sociality that are characteristic, so reproductive? I mean, what happens when you want individuals to stop reproducing?
That's a good question, and we haven't. That's something I've been thinking about, maybe seeing how far I can push this. But I have a sense that some things you can't. I mean, again, I don't think you have a honeybee colony, you poke it with a stick, they come out and sting you, which is functionally committing suicide. But they've already committed reproductive suicide because they're not reproducing. That may be very, very difficult to sort of put into a social heterosis kind of format. That may only be able to evolve those kind of really self-sacrificial traits through the fact that you sting me drives me away, and therefore my mother or my sister continues to reproduce as opposed to me eating her.
Right. And that leads to
Right.
you
Right.
lose your heterosis.
Right. But on the other hand, there's a lot of things that I think, like foraging specialists. So honeybees have individuals that go off looking for pollen, others go off looking for nectar. Some are more likely to sort of police the hive and take out dead bees and so on and so forth. So those are sort of things that are clearly beneficial for the group. And so a honeybee colony that doesn't really maintain sterility and nice cleanliness isn't going to reproduce as many as a colony that does. So I think those sort of traits, where the benefit flows back shared equally amongst the group, those sort of directly, I think, go to social heterosis. So the question then again is, in honeybees, the queen mates with 15 to 20 males habitually. So again, it's evolved this high level of multiple mating, which means that the hive itself is composed almost entirely of half-sisters. Right? So I think you see both of those elements in different traits. And so some traits, I think I couldn't force them into with a crowbar into social heterosis. But other traits, I think, just fit exactly with what you think diversity would help.
I was wondering, when you gave fitnesses to the types like A and B, do they have the same fitness given a particular heterogeneity in the group that they are in?
You mean in my model or in the, sorry, yeah.
Is it frequency dependent?
No, absolutely not. That's what we did. We kept that out. So in essence, if a group has 3 A's and 1 B, that group has the same fitness as 2 A's and 2 B's. So it's just it's sort of an all or none phenomenon in our model, as opposed to sort of.
The fitness difference between A in a group with A, B, and C, and B in a group with A, B, and C.
Yeah, so what we did in our model was we only had we had sort of one super allele that was always the fittest in any group it was in. So it was when you compared homogeneous groups, it was fitter than any homogeneous group with the other allele, and if you mixed them, it was always the best. But for simplicity's sake, all the other ones had equal fitness. So it wasn't like A is the best, then comes B, then comes B, C. It was like A, and then B, C, and D are all equal. That's the way we did it.
I have a question about the history of the debate.
Okay.
As you could characterize the two sides as actor-centered and gene-centered. And so it seems kind of odd to me that one of the most fervent people on calling the actor-centered side is Dawkins, whose claim to fame is having popularized the gene-centered view of evolution. Can you?
Yeah, I mean, I've actually never met the man. I've never even talked to him or anything. So I don't know, but he has had a historical antipathy towards group selection. You know, a lot of evolutionary biologists will believe in group selection. I mean, they'll think, you know, D.S. Wilson models work. They just don't think they work all that often. But Dawkins seems to have, like, you know, it's completely off his radar as an evolutionary mechanism. I'm not quite sure why that is. I mean, one of the things, again, I read a lot of blogs and things like this. this debate, as any debate amongst evolutionary biologists, is immediately taken by the intelligent design people showing evolution is full of crap, right? Ah, Wilson has renounced kin selection. He's renounced all of evolution. It's not true. But the thing is, there is no such thing as altruism, right? So you either have an advantage by helping your kin, or you have an advantage within your group. And yeah, it's always going to be, going back to the Nowak model, it's always going to be this trivial conclusion that a gene frequencies will increase if that gene happens to outcompete all its competitors. And it doesn't matter how it does it, whether it's within groups, across groups, or what. That's always going to happen. And so I'm not quite sure why Dawkins has this antipathy. You know, he doesn't sort of take his gene-centered view past the kin group, right? I can't explain that. I don't know why. It does seem sort of like, you know, there's some sort of bit of a logical disconnect. Because again, the group selections people are still basically saying the same thing, which is the allele has to be advantageous. It has to have some advantage and increase. And it is a gene-centered view. Anybody want to hear my one last E.O. Wilson story? Okay. So I'm really, really surprised that Wilson's gone after kin selection, because that's not the body of theory that I ever thought he'd go after. I remember I was a young PhD student, just minted, a postdoc into his lab. He would have us every couple of weeks. He would have lunch with Wilson, right? And so we're all there, got our lunch, and the first question he asked me was, "What do you think of group selection? I mean, what do you think of game theory?" Yeah, okay, it's fine. What has game theory ever done except make simple problems complex? That was his question to me. So if I thought he was going to attack some huge body of theory, I always thought it was going to be game theory he was going to go after. Maybe he's saving that until his 90th generation. I don't know. So. Anyway, there's no more questions. Thank you.